Greetings everyone. I am Uday Sharma from the Triple Department of Institute of Aeronautical Engineering. Today I am going to discuss about the topic Samsung M3 processor. Let us discuss what is a processor. In the competition of building a smartphone with higher performance, it is necessary to improve the processor. There was Samsung's first generation processor or M1 processor which did the job. Like with the basic smartphones, the Samsung M1 processor did the job of doing the regular basic tasks. And then they upgraded it to the more compact sized M2 processor, which was Samsung's second generation of processors. And that is from the first M1 generation, if the Samsung, they have reduced it to the compact size of M2 processor. Then the research and development team from the Samsung observed that by making a good few changes, the M2 processor can yield a very good output. Thus, that which lead to the formation of Samsung's M3 processor. Samsung's its very own M3 processor or its third generation processor. Upon the introduction of the M3 processor, it was a flagship processor for Samsung. Like it is a top-notch processor of the Samsung. It has higher bandwidth and had wider bandwidth and had improved latencies or lags in both core operations and cache hierarchies. Like while doing the operations, it reduced the lag or time for doing these operations. By launching this, Samsung attained higher performance and efficient power expenditure. Thus, like M3 processor increased the efficiency of this smartphone, like the basic performing tasks has reduced the time and has a power yielding capacity or power attaining capacity or power storage or expenditure capacity has increased, has also increased. The basic goals of launching this processor or the basic goals of this processor are that the performance goals to reset the M3 program to push on IPC on a breadth set of workloads within the available schedule without losing frequency versus the prior generation. Power efficiency was prioritized our absolute power, like the usage or efficiency of the basic power or the power we are having is was prior to the increasing of this absolute power. Let us discuss the performance of this. The M3 processor, the performance analysis effort, the M3 processor was broken into three phases. Each of the phases requires different abilities from the analysis team. Early trailblazing or feature mining, implementation trade-offs, and final correlation or polishing the processor. Let us discuss what is an early trailblazing or feature mining. This M3 processor. For the M3 processor, performance efforts, workloads that span both the current mobile ecosystem and the industry standard CPU benchmarks were used. The mobile side, core benchmarks such as Geekbench and Antutu were chosen. Geekbench and Antutu are the two softwares which gives the benchmark or a standard or points for in the layman's term, points or score for the process used in the phones. And the web system benchmarks like Octane, SunSpider, Bbench, and BrowseMark are also used. These are other types of benchmarking systems or benchmarking softwares used for this M3 processor. Due to the yearly cadence of the mobile processor market, the analysis team continued to look into the deficiencies of the predecessors designed throughout their design timeline using a cycle accurate simulator. Like they have considered the M2 system, M2 processor, and the M1 processor. They have continued or they have taken the deficiencies of those both two processors, and they have managed to develop a more powerful and efficient processor called M3. Any insight that could not be corrected, the M1 or M2 family due to the schedule or area had been put to the shelf for consideration on M3. like any insight or any operation which cannot be done on the M1 or M2 were taken into consideration while designing or manufacturing this M3 processor. Early in the M3 discussions, it was decided to widen the machine to 6 wide throughout, decode, rename, dispatch, and retire. Additionally, the depth of the out of order window was grown, anchored a target pre-order buffer or ROB size of 228 entries, whereas the M1 and M1 and 2 M2 had a 4-band core and 100 entry ROB, so that the M2 had to be rebalanced for the 50% growth, the width, and more than 2 depth. Implementation trade-offs is the second step in the performance analysis. The second phase of this analysis is the graduation transition to trade-off studies. As a design team began implementation, for example, the initial plan of record or POR suggested a load or store hazard queue size larger than the file size of the queue. But feedback suggested it would require significant effort to close timing unless it was reduced to size of 32 entries. A trade-off study was performed to see how much performance was lost at each size reduction in order to allow the team to make an appropriate judgment call between performance loss or an extra effort to close timing. From simulated instructions per cycle, comparisons at constant frequency taken at the end of the project across 4,800 unweighted traces, the M3 processor achieved an average of 2.01 IPC compared to an M2 at 1.26 IPC. IPCs or instructions per cycle. That is the M3 processor achieved 2 instructions per cycle, whereas the M2 processor achieved only 1.2 instructions per cycle. Will vary across specific applications and benchmarks. This broad metric shows nearly a 60% speed up in one generation. Like the M2 was 60% slower than the M3. That means the M3 was 60% fast. It can perform the tasks faster. The final correlation and polishing of the M3. The last phase of the analysis is the correlation. A set of around 700 workload snippets were used from the simplest Drystone simulations to instructions extracted from real-world mobile workloads. Nightly performance regressions are run so that any backslide of performance can be caught as soon as possible. As we can see here, this is the M3 core microarchitecture. There is a front-end, big core, load storage, and floating point. Here there is a branch prediction, decoding, rename, retire. Here is a ROB. This is a floating point where this align and this load storage. The M3 core microarchitecture is a 6-wide out-of-order design. The core features 64 KB L1 coaches, advanced dynamic branch predictors, and an aggressive data prefetcher. While the sustained instructions per cycle is 6, a peak of 11 operations can be issued, 4 in ALU, 1 in branch, 2 in load, 1 store, and 3 float in any given cycle. As we have seen in the earlier figure of the M3 microarchitecture, we'll discuss about the front-end branch prediction and the instruction fetch. The new challenge for M3 was to keep a wider, more capable machine full of useful instructions. Using a hierarchical approach allows trade-offs between capacity, latency, bandwidth, and power. Kernels with a smaller footprint can be run the micro BTB at low latency, higher bandwidth, and low FE power, front-end power. On M3, the BTB capacity was doubled to 128 entries to cover some slightly larger kernels. Optimization of the storage records allowed an increased opportunity to predict 2 branches per cycle, similar to the operation of micro BTB. As we have discussed earlier, the M2 it was 1.2 around the 1.2, but in M3 it was 2 branches per cycle. The accuracy of the main branch predictor was improved by doubling the capacity of the weight tables, trading off dynamic ranges for reducing aliasing, and by turning the intervals used to select the weights with the neural network Further improvements were also made in the indirect branch predictor. The M3 main BTB also includes a 64 entry return stack. In order for better optimization for larger footprint applications, the sizes were doubled from the L2 BTB and the instructions TLB, and the instruction fetch bandwidth from L2 cache was doubled to 32 bytes per cycle. Let us discuss about the mid-core of the mid-core in M3 core microarchitecture. In Samsung designs, the MC refers to the section including the mid-core refers to the sections including instruction decode, rename, dispatch, and integer schedules, register files, execution, and the retirement blocks. These blocks were redesigned for the increased bandwidth and the out-of-order capabilities, as well as instruction latency reduction. Here we can see the M1, M2 cluster and M3 cluster. M1 or M2 has 512 KBs, 4 bits of the 512 KBs, whereas the M3 cluster has 4 1 MBs. That is, the capacity was 2 MB of like 4 512 KBs. Here it was 4 1 MBs. That gives 4 MB. The M3 cache hierarchy was significantly redesigned for improved efficiency latencies and the ability to support increased capacities between links were generally doubled to 32 bytes per second at their inside CPU cluster. Silicon performance. Well, there are many ways to compare performance. Here, the Geekbench is the standard set or taken into the consideration while calculating the power or while analyzing the power. Is an important test. Geekbench is an important CPU stress test for smartphones. It gives all the different types or different systems to consideration it takes and gives a mark, combining both IPC or instructions per cycle gains and a higher productized frequency. M3 achieves a net speed up of 60 net speed up on Geekbench version 4 single thread of 85% comparing that of to the M2. As we can see here, we have taken into consideration of three types of processors of Samsung: Samsung A75 processor, Samsung M2 processor, and Samsung M3 processor. As we can see, of Samsung's M2 processor and M3 processor has significantly higher gain than the M2 processor. These were some of these tests taken into consideration in the Geekbench Week 4, like camera, HDR of this camera, blur, speech recognition, face detection, memory copy, etc. Were some of these products or some of these systems taken into consideration while calculating these marks of the Geekbench. The goal of the part team was to drive performance or power efficiency in the right directions as much as possible, using techniques like clock gating. However, at a system level, additional trade-offs can come into play. Mobile smartphone systems consist of a mix of big and little cores. The system tends to start with the little core and only migrate to the big core when performance demand justifies it. Like the small core is used first for the basic tasks. Only the bigger core, the system transfers the work to the bigger core when the performance or the load demands. Also, the system software includes DVFS controls that boost the throttle cores as needed. And tasks will tend to start at a lower frequency and only get boosted as further performance is demanded. Like every other task is started at the lower frequency and then again boosted based on the performance or demand. Many user interactivity scenarios only require brief bursts of higher performance to satisfy demand, which can be dealt by the temporary boosting core frequency. Like mostly every other task required only a smaller core. They only require the bigger core or the boosting of this frequency for a short period of time. This can be done by the temporary boosting of this core frequency. So I want to conclude about the Samsung M3 processor. Thank you. This is Uday Sharma signing off.